So today we're going to look at this thing here, which is a Keithley 181 nanovoltmeter. I haven't powered this up yet. I purchased it a couple of months ago. It's been sitting around for a while now. Haven't powered it, got no idea if it works properly. We'll find out. It actually comes with the actual connection on the front, which is nice, because these are a bit harder to find. Special connector, because it's all nanovolt rated, you know, so low leakage. And it's got bananas on the end of it, and also a clip lead. Okay, so it's paired it off. So they've got clip leads and bananas on the same connections. Right, these look like nice clip leads. They actually look like just copper clip leads. Whether it's something someone's made up or what, I'm not sure. This currently is not changed voltage, I don't think. Let's have a look on the back. It might just being that voltage. Where did I get this thing from? It's marked as 210 to 250. I'm just trying to remember where I actually built this thing from. Whether it actually is there or not. We'll have to open it up and have a look. I want to make sure before I power it in case I blow the back end of it. So obviously it's got GPIB and it's got some analog outputs on the back here as well. So if you want to hook this up to like a digital meter, which has got high resolution maybe, I don't know, or some logging system or something like that, you potentially do that. Interesting, it's got this RFI shielding sticker on here. I wonder if that's an option or upgrade or something. It has 6.5 digits on it, but I don't think it actually is 6.5 digits. I think it's only like 5.5 because the first one's potentially enunciator. Obviously a big clunking power switch, which is always nice, and obviously the inputs here on banana jacks. So we'll have to have a look at this and see if it even goes. Hopefully it does. Alright, let's get the cover off and have a look inside, see what we're dealing with. So I've got no idea, I haven't researched it, I haven't read the manual. In fact, I'm not even sure I've got the manual for it. I may have downloaded it. I may have done, if there was one. Is that enough to get it off? It is. So it's got shielded casing, that's nice. Lots of film caps. Just adjustments on the top edge of here, that's nice and easy to access. Shielded can. Calibrated by 1065 and setted by 1300. We've got some dates now. You can see 84 on some of those chips. 84 on those ones as well, so I'm guessing this is 1984. And there is indeed a selector switch down there for voltage. So there you go, there's a switch down there for voltage selection. It is indeed on 230, so great. I don't have to change anything there, so it's safe to plug in. That's brilliant. A little setup in there, first I've seen this done. So this, like, basically it's a long leaded socket which is all offset, so it's got the dip switch on the back. I've never seen that done before, that's interesting. Quick visual inspection around it, I've had a quick look. Nothing obviously bad apart from one capacitor. This one here, it's very wobbly, like it's extruded at the bottom, and the top is very slightly bulged. That is bulged, so this cap is gone. Now you also got these other smaller ones down here. They're dead flat still. The ones over here, there's a couple of small ones down there too. They're looking alright. Visually look okay. I'm not seeing any leakage on the board, which is a good sign. But that big cap there is definitely gone. That's bulging. It just, nah, that's not right. I'm tempted to just replace them all. There's not many caps in there to replace. Let's take the shield off and have a look underneath the shield. See what's going on there. Interesting screws. They don't seem to screw in very far. I'm not sure if it's falling apart or if something else is going on. I think it's falling apart. Cover off, yeah, okay. There's a sandwiched cover and the bottom cover fell off as I was unscrewing those. There's a panel underneath this PCB as well, which is now floating around. So that's what's under there. Always pays to have a look. We've got a voltage reference over here, I think. LM399. Yeah, LM399H. Voltage reference. No cover around it, I'm surprised by that, but then it is inside basically a sealed enclosure. There shouldn't really be any airflow unless there's no fans and no vents, so it should be okay really anyway. Whole enclosure will be probably alright. Oh, it's worth covering it though. Is it worth it? I don't know. There's poly cap over here, film cap, some precision resistors, obviously a few adjustments and stuff. But so over here we've got some connectors over here which go to this board, which go through this inductor. Basically it's a ferrite there with it round, going to the input jacks there. So I'll put my gloves on because I want to take this board out and see what's underneath it. And this is covered in position stuff. You got these Teflon standoffs here, these isolators on the board. So it's all precision, you don't want to mess with this and get it dirty. So that's why I've got the gloves on. I'm going to pull these terminals off here. I think I might take that screw there off as well, maybe. Looks like it is a standoff. So I've already taken two screws out. but it's got these little headers down here which push in. So what I'll do is I'll lift the board off, I'll put some deoxit on these to clean these up a little bit, and then I'll reseat it as well. Reseating the connectors is always a good thing to do, because I do gradually tarnish. So before I take this board out, I'm just about there. I've just got to lift the thing off basically. These capacitors, right, I really hate this design where people will put all the power stuff together, which is fine, you know, in a way. You think, okay, you're going to put your smoothing circuitry in, your filtering right by your regulator circuitry, which is sensible. But when you're sticking capacitors right next to a heatsink, that's not good, because these things get hot. It ages the capacitors much more rapidly, and instead of getting, you know, 30, 40 years out of a cap, you might only get 5 or 10, maybe, I don't know, depending on the caps. But you know, having a rapidly aged cap, and this one here is definitely gone bad, and that's because it's next to this massive heatsink here. Alright, so the heat from this is radiating the capacitor and aging it and making it dry out quicker. You know, the hotter they are, the shorter the lifespan. So putting capacitors next to heatsinks is one of my pet peeves, and it's so commonly done. If you ever design anything, don't put your big bulk caps next to heatsinks. Move them away, even if you're only like 20mm away from it. You know, just a bit further. Just get them as far away from it as you can, because this is not good. And this is from a Keithley. Right, let's try and lift this board out. I've got all the screws out now. Here we go. So I fold it over. You can see all the Teflons really clearly here. Got the shield here which can come off the bottom. That's those little screws went into. It only barely went in, literally only a couple of threads in. Whereas bolts are a little bit short. That's what's underneath. So there's that stand off there, which I have to be careful of. Got some chips. You've got an EEPROM over here. 181B9.1. I wonder if I should pull that and back that up. Probably be an idea to, eh? I might go and see if it's available online first in case I'm wasting my time. So I've refitted that now. Put the cover back on again. That was a bit fiddly getting it in there. It wasn't that bad, but you had to kind of get under one corner under here and get that one screw in, and then that screw in, and that one and that one. So a bit of messing around, but it's back together now. So I think we can actually power it up, because, well, mind you've got that capacitor to do yet. Just take this bottom cover off, then we'll change the caps, I think, before we do anything, because otherwise we might have a problem with it. So I've got to try and get this bottom cover off now. That's being tricky. The board has actually got these little circular standoff things that go over it, which go through to here. There's one underneath this board here. I've got to take this board out to get to it. This one here I've taken off, which I think is okay. That's all I've got to do. That's a screw I can still get to, thankfully. Then I'll take the cover back off again. That would have been annoying. But I've got a board here which looks like I've got to lift it out, so I can get to the other screw, which I didn't mind lifting out anyway, because I wanted to reseat connections anyway, so that's fine lifting it out. Ah, there might be, might have a problem after all. Let's just lay this down. So there's two of those plastic standoffs down there, those little mounts, which means there might be one under that board after all, which means I might have to take that board back out again. There probably is one, isn't there? What's the chances? The chances are quite high that there's one underneath that board, so I have to take the board back out. Well, I'll actually put some deoxit on it, then I'll put it back in. Trying to catch the excess spray. Right. Don't have to go everywhere, I only want it on the pins. So put that back in. I think there's another standoff. That side's moving. Yeah, I've got to take the board back out again. That's annoying. So after a massive amount of effort, a lot of tinkering around, just trying fitments and things, figure how to get the board out. It is a mission. You have to basically strip all the vertical riser out and everything like that. So you've got the board, basically the bare board now. Like this. So the transformer's attached to the board, that sort of stuff. You have to remove the rear panel screws. There's two screws in the rear panel, take those out. So it frees it from the side panels. And then you've got to try and slide it forwards a little bit. You've got to lift it up a bit and then slide it forwards to push basically the power switch as far forward as you can, to get it forward, to create a gap at the back to get it around this little bracket here, because because you can't get the board out otherwise. You've got to get the board around this side of that bracket, and then you can lift it and lift the board out with the rear panel. It's a really tight fit. It was not a good design. So anyway, we've got it out. Now we can actually try and fix these caps. So I'm going to take these rear panel connections off as well, just to avoid stressing the things. Nut drivers, brilliant things to have. Highly recommend you get one if you don't already have a set. This particular one is a 8mm. Fits on those perfectly. Well enough anyway, maybe not perfectly. So now clear those off and get the back panel out of the way. That filter's made in Barbados. Interesting. In 1984, 14th week, 84. That's the actual filter, so it's got 3 caps in it and a couple of inductors. Common mode inductor with a ferrite. So let's pull those 3 1500 microfarad caps out. I'm going to replace those with 2200 because that's what I've got. 25 volt, and these are 25 volt as well. So slightly higher ratings, higher capacitance levels. So I'll put these ones in. Obviously you always check polarity. You don't want to put a cap in wrong. Put a cap in backwards, you're going to have a problem. You find out pretty quickly usually. And usually there's a clue about which one it is. Now I'm going to take the big cap out, one which is bulging, so it's just here somewhere. I think it's those 2 pads just there. So let's try and wiggle this out. Just clearing the holes out as I go. Negative with downwards. So there we go, 10 volt. $10,000 at 10 volt, and I'm putting in a 10,000 at 16 volt. There we go. So what I might do now is actually solder those ones in before I do the smaller ones. Otherwise you end up with all these leads sticking out everywhere. If I put flux on this board, it's going to make a mess. I might try it without flux first, see if we can do it without flux. Looks like it's going to go right. Because it's double sided, I've got to try and get the heat right through the board and get the soak to the other side, so it also attaches to the other trace. It's barely okay. Also, being a capacitor, you don't do it too much because you can actually damage the cap if you overcook it. Because don't forget the heat goes right up the legs into the cap. So there's a bit of a trade-off there about instinct. Which one do you think you need to go for? How long? I'm also watching for the solder disappearing, so like the level will drop down as it goes through the board. As it wicks through, so I'm kind of watching for that happening as well. There you go. I'll clean the board up afterwards once I've done all of them. What I might do, because this one's quite standing off, it's the leg spacing wasn't quite the same. So this one's a bit wobble, like the original one was. The original one was the same actually. It wasn't sitting right down. So I might actually put something on the board here just to help support it. Some liquid something just to help attach it to it. This is not worried about because it's pretty small, but this one's quite big and heavy, so I might just do a little bit on that. But I did it afterwards. Maybe if I don't forget. Let's do these ones over here, these 100s. So those are 100s at only 85 degree rated as well, 35 volt. And I'm putting in 100s at 100 volt because that's what I've got, which is similar sort of sizing and stuff. That leads me to the 5 smaller ones now. So it's basically reassembled now. It's got to do a few more bits. I've got to put that bottom panel back on again, put the top cover on. I think everything's back together. I don't think I'm missing anything yet. What I'm going to do is I'm going to put some of this liquid electrical tape underneath this cap here to help brace it. I'm going to try and lean it away from that heatsink to keep away from it. And I've already kind of done the same thing with these ones already, trying to lean away a little bit. But this one here I'm going to lean away quite a bit to try and stop it from aging prematurely. So let's check the capacitors out of interest. So this is the 10,000 microfarad 10 volt. There we go. So that's actually lost half its capacity. So yep, definitely bad. This is a 1500, I think it is. Yeah, 1500 25 volt. A little bit low. ESR's not looking too bad, 0.1. Same again. Yeah, okay, not too bad. Same again. Again, not too bad. It's got slightly higher capacity. So it's quite a broad range here across those ones. This is a 1000 microfarad 35 volt. Yeah, I think that's dead. What do you reckon? 58 microfarad, 18 ohms. Yeah, that's gone. This is why I recap these things. Even though it looked fine, no, it wasn't. This is another one the same. It's getting 50 at 24. Yeah. Both of those are dead. Next one is the 6.8s, 25 volt I think they were. 7.4, 18 ohms. A little bit on the high side, but it's a small value, small voltage, so they are going to be a little bit higher, but I think that's probably no good. 21 ohms, yeah, 7.2 microfarad though. Capacitance is looking okay, but the resistance is looking a bit dodgy. 19 ohms, 7.2. I mean, generally my experience has been that smaller capacitors tend to die. 17 ohms, I mean, that's marginal. Last one here. Smaller caps seem to be more prone to it anyway. 23 ohms, yes, dead. So yeah, I think basically you could say all those caps are bad. Let's power this out for the very first time. I'm confident now the caps are all good, at least the ones that matter. There's tantalums in here, so we could still have an issue. Could be a shorted tantalum, you never know. It's a thing. As long as the power supply is good, which is part of the reason I wanted to change these caps, the tantalums will probably be good as well. And the problem is, when you get a lot of ripple on a power supply, go and take your gloves off now, you can go. What happens when you get a lot of ripple on a power supply, it puts a lot of stress on the tantalum caps. Tantalum caps don't like a lot of ripple. I mean, they are obviously a smoothing cap, but they like impulse noise, not AC ripple waveform. They don't like to be stressed, and if you've got a lot of AC ripple and it's close to the voltage on a cap, these tantalums tend to be a bit close to the actual voltage you're running on, the actual ratings they use. You really want to double it at least, ideally triple it, right, to get plenty of headroom. So we're nowhere near the maximum voltage rating of the cap. Because if you've got an AC ripple coming through and you've got, say, a 50 volt rail, and you've got an AC ripple coming through, you can be getting 20 volts AC easy. If you've got a 25 volt cap, you're getting a bit close to that margin, and when they're getting a bit old, that's a real problem. I've seen them blow on power supplies where they shouldn't have blown purely because of AC ripple. Because the AC ripple was getting really close to that tolerance, so I always give them plenty of headroom. Power on. No current draw currently. Good sign. Means the filter probably is not blown yet. Let's give it a minute to see if anything happens. Okay. I haven't checked the fuse. We'll see. The fuse is after the filter anyway, but you know. Anyway, let's push the button. Do we have power? We almost have power. I forgot to plug something back in again. I forgot to plug the display back in. We'll try that again. Now you have a display. Current draw is 13 watts, 71 milliamps drawing on AC. That's looking fine, there's nothing horrible there. And we actually have a reading on display. So that's looking promising. So do say 20 volt range. Ranges are working. So yeah, that's working, working. It's changing ranges, so it's responding to the buttons. High res mode, whatever that does. Guess it does high res, zeroing, yep. Filter, damping. Okay, all the buttons seem to be working. That's a good thing. Let's zero that. Let's plug the PDVST mini in. Careful where I stick my fingers. Turn this on. Let's do 1 volt. No, it's reading it. It's slightly down, but then this has still got to warm up. 5 volts. Yep. 10 volts. Well, it's working, but it seems to be out by quite a bit. Okay, let's go down to 1 volt. It does have a LM399 reference in here too, so it probably needs to be warmed up too. So 1 volt is reading over on this range. So this range is reading high, and this range is reading low. I don't think that's a reference problem. I think that's a calibration problem. So that is at least working. So let's go down to 100 millivolts. That's looking good there. 2 volts, again reading high. 200 millivolts. That's off that input. Let's change connections. Actually, before I do that, let's go up here. Let's do 10 volts. Let's do the higher ranges, see if they're working. 10 volts in that range is working, and on that range is working. Great. So that all those ranges there are working. Let's check these lower ones. This is this ball down the side here, this big can on it. So that's a lot of thread to do up. Let's keep going. I'm into it. Alright, drop the voltage right down. Let's do 1 millivolt because that's safe across all 3 ranges. And we've got this weird setup on this cable. We'll just plug into that. Convenient but weird. Okay, so on a 2 millivolt range, get an overflow. Oh, I'm doing 100 millivolts. Not why, that's why I'm doing 100 millivolts, not 1 millivolt. 100 millivolts, there we go. So that's working, that's really good actually. Let's do 10 millivolts. Sure, I could have done that a quicker way. 10 millivolts is a bit low there. That's working there. Reading a bit out slow, but probably within range. I don't know exactly what this output is. I could check it out my. I actually need to hook this up to my 8.5 digit meter and actually do some calculations what those actually end up being. But it's working. Okay, 1 millivolt. Again, I could have got there a better way. 1 millivolt. That's also working but reading out. But it could be rounding on this thing because this is a digital analog converter. It works. I'm happy with that. Now, how stable it is, you see it jumping around us then. Put a filter on there. Does that help? Not really. Damping, whatever that does. I guess damping is like an averaging. Let's do high res. Extra digit. Nice. So this is basically 6.5 digit meter. Well, let's go back up to a reasonable range and check for something which is more or less known or less noise prone, I should say. Back to 1 volt. Yes, that's definitely doing damping there, look. Turn it off, straight to it. So yeah, that's like an averaging. But it needs calibrating, that's fine, I can do that. I'm not going to do that now, because it needs to be warmed up for a few hours and that sort of stuff, you know, at least. Because it's got a reference in there. So I can hook this up on my other test gear, my calibrator, the other side there, and do that later on. Yeah, because these leads are a bit like this, can be picking up noise in those low levels. They're not ideal for that. really it needs a different kind of connector and different lead setup for those doing these like really low levels like that. But it works, that's the main thing. Hasn't blown up, there's no magic smoke, it just needs calibrating, and that's not a big deal. That's that done. Now, I should have actually used this button earlier on.
It's always a capacitor.
It's always a capacitor. And
click subscribe right now, quick, before you forget.
Just like my desk says, subscribe, click like if you liked it. Other videos down below, don't forget to subscribe over there. Patreon support link over there. Patrons help me to buy things like this. So the money from Patreon goes directly into buying broken test equipment to do videos about. That's what I use the money for. So if you want to help me to make more content about these kinds of things and bits of equipment, if you go on Patreon, it's only like a couple of dollars a month or a bit more if you want to do a bit more than that. A couple of dollars is all it is at the minimum. It doesn't cost you much at all if you want to help support the channel. The more people that do it, the more bits of gear I can buy and the more videos I can produce about fixing pieces of broken gear. So if you want to do that, it's great. Right, catch you later.